Hi everybody. Today we're going to start and we're going to take a look at some more pieces of a circle. The first piece that we're going to take a look at is sectors of a circle. So here you can see I'm talking about the sectors of a circle, and the sector of the circle is this pie-shaped piece right here. We call that a sector. It is a fraction of the circle, so we're going to be using fractions of this of 360 to be finding the area of these sectors. The next piece that we're going to talk about, and this one you may not have heard of, is a segment of a circle. The segment you can see right there is this little piece that is formed by it looks like we've got the sector right here, this little pie-shaped wedge, but then, oh dear, that's what I meant to do. But then we have this triangle and this arc, and the segment is that little piece between the triangle and the arc. We call that a segment of a circle. And we're going to look at how to find the area of the segment of the circle too. That's kind of a composite relationship. The next thing that we're going to look at is arc length. And arc length is not the same as the measure of the arc. Remember earlier in the last section we talked about the measure of the arc is congruent to the measure of the central angle. Well, now we're talking about the specific length. So this length of this piece of the circumference of the circle. And that has its own special formula. It's a fraction of the circumference. So we're going to be looking at those as we go forward from here. So let's start with the area of a sector. So we can find the area of a sector by taking a look at what fraction of the circle is the sector. So in this case, you can see we have a 60-degree central angle. So you can see our formula is A equals pi r squared, that's the area of the circle, multiplied by this fraction of the circle that we have. So in our specific case for this one, we will have that our area equals pi, we said our radius is 3 squared is 9, and then times our fraction of the circle, which is going to be 60 degrees over 360 degrees. So we'll multiply things together. So we could say A equals pi times 9 times 1/6, or A equals pi times 9 over 6. Reduce the fraction, and so we'll have that our area of our sector equals 3/2 pi, or 3 pi over 2. Let's be careful. I want to make sure we write that how we mean that. So when I write that, I want to say either 3/2 pi, but I don't want that pi in the bottom. So either of these I'll take, if that makes sense. So that's how we find the area of a sector. The next thing we're going to look at is the area of a segment. Again, we said that the segment is this little piece right here. Just this little piece formed by this chord and that arc. To find the area of the segment, what we're going to do is we're going to say the area of the sector. So here's our sector. And then we're going to subtract this triangle, and that will leave us with our sector. So you can see, we'll take the triangle, and that'll leave us with the sector. So the area of the segment equals the area of the sector minus the area of the triangle. So that's what we'll be using for that. Then we have arc length. Arc length is represented by L. So L is our arc length, and we will find it by saying, again, like we said earlier, that that arc length, L, is a fraction of the circumference. So 2 pi r is the circumference of the circle. So, and our fraction is whatever our central angle is, m degrees, divided by 360. All right, so let's take a look at this problem that we have. We have that the radius of a given circle is 3 centimeters. Find the lengths of the given arcs and the areas of the sectors determined by the given arcs. We're going to leave this all in terms of pi. So, for the first one, we have our arc measure is 50 degrees. So we want to find our arc length. So our formula for arc length is A equals, and it equals the fraction of the circle. So that's 50 degrees over 360 degrees. Times arc length, that's a piece of that is the fraction of our circumference. So that's going to be times 2 pi r. So we're going to put our information in and we're going to find that answer. Then we're going to come over here, we're going to do the area of the sector. So the area of our sector is A equals, again, our fraction of our circle, 50 degrees over 360 degrees, times, in this case, pi r squared. So those are the formulas that we're going to use all the way down. Now, in the video, what I'd like you to do right now is I would like you to work on getting these answers. So I'd like you to pause it right here, work on getting your answers, leave everything in terms of pi, don't get out a calculator. You won't be able to tell if you got the right answer because I don't have calculator answers. So don't get out a calculator, leave everything in terms of pi, and see what you get. So go ahead and pause for just a moment. And when you're finished, go to the next page. And, or when you continue, I guess you'll be on the next page. And so what I got for the arc length of the 50 degree was 5 pi over 6. For 140 degrees, 14 pi over 6. For the 210 degrees, 21 pi over 6. For the area of my sector, I ended up with 5 pi over 4, 14 pi over 4, and 21 pi over 4. So those are what I ended up with. And if you ended up with something different, you might want to go back and take a look at it. Ask some of your classmates tomorrow how they did. And go from there. The next problem that we have is to find the area of this segment of this circle. Okay, so the segment is this turquoise shaded area. It's the area between the chord right here and the arc of the circle. So to find the area of the sector of the segment, remember we said the area of the segment equals the area of the sector minus the area of the triangle. So let's see what we've got. So to find, sorry about that, to find the area of the segment. So the first thing that we're going to do to find the area of the segment is find the area of the sector. So to find the area of the sector, so I'm going to come down here, I'm going to say the area of the sector. And the area of the sector equals what fraction of the circle. I've got 120 over 360 times the area of the circle, which is pi r squared. My r, let's go ahead and put that in. What is my radius? That is 6, so that's going to be 36. So let's do some canceling. Do a little bit of canceling here. Cancel out my zeros. Cancel out my 36. And I end up with 12 pi. That's the area of my whole sector. So now I've got the area of my sector. I'm just going to write it right here. And now I've got to subtract the area of my triangle. So let's come over here to the triangle and let's take a look at this triangle. So this triangle, let me do this first. It's a central angle, which is the same as the intercepted arc. So my central angle is 120. That means if I were to draw this radius, wow, that's not what I meant to do. If I were to draw this radius perpendicular to that, then I create a 60-degree angle right there. So I have a 30, 60, 90 triangle. That means that this piece right here is 3, and this long leg right here is 3 square root of 3. So now, the area of a triangle, let me move that. The area of the triangle is 1/2 base times height. So my base of my whole triangle here is going to be 6 square root of 3. My height is 3. And so I've got 1/2 that. So I end up with 1/2 of 18 square root of 3. So that is 9 square root of 3. So the area of my segment is 12 pi minus 9 square root of 3. Whew. It's a lot of work for those segments. All right, let's try this one. I want you guys to try it again on all of these problems. Anytime you look at it, you try it first, and then pause the recording, come back, and you can find out the answer as we go through it. So let's take a look at this one. So pause it right now if you want to do some work on your own, and then come back. So when you come back, here we are. We're taking a look at this. I'm trying to find that segment, and I see that that's a 90-degree arc. That means that's a 90-degree central angle. I know these are both radii. So that tells me I have what kind of triangle if I drop that to be perpendicular. That tells me these are 45, 45, 90 triangles. So that's going to be 45. All right, and that's going to be helpful because we're going to need that when we do our sector minus our triangle. So again, we're taking a look, and I know that the area of my segment equals the area of my sector minus the area of my triangle. Okay, so the area of my segment. All right, the area of my sector. The sector is 90 over 360 times pi r squared. What's r? See down here it says that my diameter is 8, so r is 4. So that is 4 squared, which is 16. All right, so I've got that. I'm going to do some canceling out again of things. Cancel my zeros. I take a 4 out of everything. That leaves me a 4 and a 9. Those 9s cancel. So that leaves me with 4 pi. So 4 pi is the area of my sector. So now I want to find the area of my triangle. So I come over here to my triangle. So I need to know 1/2 base times height. So my base, if this is a 45, 45, 90, this is 4. My radius is 4. So, and that's my hypotenuse. So that means that I divide by square root of 2 to find my legs. So that's going to be 4 divided by square root of 2. I have to rationalize that. So that is going to be 4 square root of 2 over 2, or 2 square root of 2, which means that this is also 2 square root of 2. So my base then, so for my area of my triangle, I have 1/2, and that is 4 square root of 2 is my base, times 2 square root of 2. When I multiply that together, I end up with, I can do this 1/2, that leaves me with a 2. So I've got 2 square root of 2 times 2 square root of 2. 2 times 2 is 4. Square root of 2 times square root of 2 is 2. 4 times 2 is 8. So the area of my triangle equals 8. So the area of my segment equals 4 pi minus 8. 4 pi minus 8. All right. I hope you guys are catching on to this and understanding what's happening. All right, so let's look at this one. Now I want to find the area of the shaded region. That is, I want to find the area of the yellow shaded part. That's the part outside the rectangle, but inside the circle. So I can do this. I can do this by saying that the area of my shaded region equals the area of my circle minus the area of my rectangle. Does that make sense? If I take the area of my whole circle, subtract the area, so take the area of the whole circle, subtract the area of this triangle, then that leaves me the area of the shaded region. Sounds good. So, area of the rectangle is easy. It is 16 times 12. So, we've got that piece. That's 192. So, I got that. 192. No problem. Now, the area of my circle. Okay, the area of the circle is pi r squared. Well, my problem is I don't know what my r is. How can I find r? I want you to pause the video for a minute and I want you to think about it. How can we find r? So go ahead and pause. Okay, if you're back, I have decided that I can find r if I use the Pythagorean theorem to find this diagonal, which also happens to be a diameter. So I'm going to use my Pythagorean theorem, and I end up with that this is 20. Check it out. So that's 20. So that means then my radius is 10. So 10 squared is 100. So the area of my shaded region equals 100 pi minus 192. And that's how we're leaving these in terms of pi. One more. This one's a doozy. I like this one. So what I want to find on this one, I have two circles. They have radii of 6 centimeters, and their centers are 6 centimeters apart. So I want to find the area of the region that's common to both circles. Okay, so I've drawn these other two black lines in, and I know that they're also 6. because they're radii of my circle. And I've got to figure out how am I going to do this? How am I going to find this? And what I see when I look at this is I see that I have this sector and this sector, right? So I can find the areas of those sectors. I know how to do that. And then I have this segment and this segment. I can find the areas of segments too. So, having that game plan, why don't you take a minute, pause the video, and see if you can figure out how to find the area of that shaded region in the middle. When you come back, I'll show you how I did it. So what I have is I'm going to find the area of just one of the sectors. Okay? So again, here I know that this is 6, that's 6, and that is 6. I'm talking about these lines right here. So I know that those are 6. So to find the area of my sector, I need to know so first thing that I need to know is what percentage of my circle is it. So that means I'm going to need some angle measures. Well, that's a radius. That's a radius. So all of these are 6. So that means, if you'll take a look, that means that I have equilateral triangles. If I have equilateral triangles, what's the measure of the angles I'm looking at? I'm talking about 60-degree angles. So the area of my sector is going to be 60 over 360 times pi r squared. We know that r is 6, so that's going to be a 36. Those cancel. So I end up with 6 pi for one sector. I have 2 sectors in here, so that means that for my 2 sectors I have 12 pi. So that's my sector. So area of sector is that, 12 pi. So now I want to find the area of my segments. To find that area of this segment right here, let me go back. I want to get, that's not what I wanted to do. To find the area of my segments, what I'm going to do is I'm going to take this sector and I'm subtracting, I'm going to subtract one of the triangles. So for one sector, we said that the area is 6 pi. So for that segment, I'm going to say 6 pi minus the area of the triangle. So we said these are isosceles triangle and equilateral triangles, right? So they're equilateral triangles. Each of them are 6, and their angles are 60. So if I drop this down, I can find the area of my triangle. So 30, 60, 90. So this one's 3. That's 6. The height is 3 square root of 3. Okay, so I've got that. So the area of the triangle then is 1/2. My base is 6. And my height is 3 square root of 3. So basically what I have here is that I have one segment is 6 pi minus 9 square root of 3. But I've got 2 of them, right? So 2 of them are 12 pi minus 9 square root of 3. Oops, not 9. hold on, minus 18, square root of 3. All right, so that's 2 of them. So my total shaded region then is, let's go back and take a look, make sure we've got it right. So my total shaded region is going to be that sector, right? So that's one of these, 6 pi. This sector, this sector, that's another 6 pi. That's my 12 pi. All right, then I'm going to have these 2 segments. I've got to add those 2 segments, which I found my segments to be this right here. My 2 segments are 12 pi minus 18 pi over 3. So I'm adding those to so I'm going to add the segments to my sectors. So I end up with a final answer. I'll put my final answer up here in a different color. But my final answer right here is 24 pi minus 18 square root of 3. Whew, that one was long. So, but there you have it. And it's not really that it's long, but you have to really think that one through. So that's the answer there. So I hope you had fun with those. On this next slide, I just wanted to make sure that we kind of recap what we did. So we talked about sectors, and we talked about segments, which are these little areas, and we talked about arc length, L, which is different than the measures of the arcs, right? When we're talking just about the measure of the arc, we're talking about that the measure of the arc equals the measure of that central angle. But when I'm talking about arc length, I'm talking about the fraction of the circumference of the circle. So make sure you've got that straight. So okay, so your homework, so what I'd like you to do for a little bit of practice tonight while you're listening to the video is I would like you to go to the guided practice, which is on page 2004, I believe. And I'd like you to do numbers 1 through 4, and then skip 5 and do 6 through 10. So basically 1 through 10, skip 5. And do those for some practice. And then tomorrow in class, you'll have your regular assignment that will be on my homework app for you to work on in class together. And then we'll do another homework video for homework that night with a little bit of practice. And so these problems, 1 through 4, 6 through 10, are due at the beginning of class. You'll just turn these in to Mr. Medlin, and then you can work together on the in-class assignment. And we'll hang on to that, and I think that's it. So thank you guys very much, and have a good one.